Hello everyone, welcome to CodeTav Management, to our topic 3 of our AI engineering playlist. So in the previous videos, we learned like what AI engineering is and why Python is important. Now comes the foundation of everything, mathematics. So a lot of people just get scared hearing the word math. But here is the truth. For AI engineering, you do not need advanced mathematics. You only need practical concepts. And in this video, we will focus only on those. So why math matters in AI? So AI looks magical from outside, right? But internally, it is like pure mathematics. Just think of it like AI is the combination of mathematics, data, and code. So without mathematics, there are no embeddings, no probability predictions, no neural networks, and no optimization. All actually depends on math. So if you understand the math, you understand how AI thinks. So math roadmap for AI. Here are the main math areas you need to know. First, linear algebra. Why we will learn the linear algebra? So this basically helps in vectors and matrices. The second thing is probability theory. So this basically powers the predictions. Next is statistics. So this basically helps understand the data. Next comes the calculus. So we use calculus for optimization purpose. And finally, optimization itself. So this basically helps models learn. So that's the math roadmap you need to follow for AI. Now, first of all, vector. So a vector is like simply an ordered list of numbers. So in the example, you can see like 0.12, 0.44, 0.89. So this might look simple, but in AI, this is powerful. Why? Because text, images, and audio are converted into vectors. So these are called the embeddings. Like from the text, images, and audio, when it is converted into this type of numbers, so that's the process we know as embeddings. Okay. So every LLM works heavily with vectors itself. Now, vector properties. So vectors have three important things. So maybe in physics in your school days, you have already learned about vector, like scalar and vector, right? So vector have three important things. One is magnitude, one is direction, and another is distance between vectors. So magnitude actually tells how big the vector is, direction tells where it points, and distance tells how far two vectors are. So in AI, distance basically helps us to find similarity. Okay, we will learn more about that. Now, the concept matrices. So a matrix is a collection of rows and columns. So you can think it like a table of numbers, like suppose in one row there are 1, 2, and then 3, 4. Like a simple example, I'm just adding here. It's look like 1, 2, and in the next row, it's like suppose 3, 4. So that is basically the matrix structure. Just forget about this. Like this is a whole. Okay. So why is this important? So because neural networks store the weights in matrices. And what is weight? That we will also learn in further. Okay. So models basically perform the calculations using the matrices all the time. Okay. So that's the basic concept of matrices. Okay. So there are like multi-row matrices, like 2 by 2 matrices, 3 by 3 matrices, m by n matrices. Many types of matrices are there. Next is matrix multiplication. So this is the heart of the deep learning. Like input multiplied by weights will be output. So every neural network layer does this. So just imagine input data comes in, then weights transform it, and output moves it to the next layer. So with the help of input and weights, like the incoming source data, and then through the transformation through the weights, after that we will get the output and that will be moved to the next layer. So this process repeats millions of times. So layer by layer, in that way it will be proceed. Now the dot product. So the dot product means like it measures the similarity. So if two vectors point in similar directions, the dot product is high. Why is this useful? So search engines use this. You know the Google search engine, right? So there also this kind of thing is being used. So recommendation system use this. Vector databases use this. So this helps AI understand related information. Okay. Now cosine similarity. So this is one of the most important concepts for AI engineers. Cosine similarity measures the angle between vectors. Smaller angle means higher similarity. So this is heavily used in semantic search, vector databases, and RAG systems. So this is how AI finds relevant knowledge. So suppose in some chat GPT or some any model, okay, so there you are searching something. So it basically gives you the related topics as well. So through the cosine similarity only, they can search and give you the proper result. Next, the probability basics. So probability means predicting chances, like what is the probability of rain. So in AI, what is the probability of the next word? Okay, so LLMs work exactly like this. So they predict the next token based on the probability. Next comes the conditional probability. So this is where LLMs become powerful. So like P, next word, previous words. So what does it mean? So what is the probability of the next word given the previous context? For example, you will just type hello. Okay. The model may predict like world, friend, there. So based upon the previous context or previous word, it will suggest you the next word. So each with different probability. Okay. So that's the foundation of LLM generation, the conditional probability. Next, we need to know the statistics basics as well. So statistics helps us to understand the data. So like why we will use the mean for average purpose. To find the middle value, we need the median. To find the spread, we need the variance. And to check the consistency, we need the standard deviation. So before training models, data must be understood. So we need the mean, we need the median, variance, standard deviation. So whenever we will like to train the models, so before of that, data must be understood. So statistics helps with that. Why statistics matter? So in AI engineering, data is everything. Statistics helps to find the outliers, to clean the data, understand the pattern. So if you will get bad data, that gives the bad models. That's why statistics matters. Whenever we will get some data, we will do some analysis through the statistics. If we will able to uh, find out that that data is good data, then only we will proceed with that to build a model. Now the normal distribution. So most real world data follow the normal distribution like heights, exam scores, temperatures. So this bell curve appears everywhere. So in AI, Many assumptions are based on normal distribution. Like understanding this helps in analyzing the data sets. Next is calculus in AI. So calculus sounds scary, right? During our college days, like class 11th, 12th, in that time. But in the AI, you only need one idea, the change. Like how much did error change? How much did weight change? So that's all. Calculus basically helps models understand how to improve. Next is gradients. So a gradient basically tells us the direction of fastest increase. But in AI, we want to reduce the error. So we move in the opposite direction. So this tells the model how to adjust weights. So this is how learning happens. Next is gradient descent. So gradient descent is the process of reducing error step by step. So think like climbing down a hill. So at every step you move lower. So until you reach the bottom, that bottom is minimum error. So that is how AI learns. Okay. Like whatever weights are there, on top of that, we are not just correcting the output. With managing the weights, we will correct the output. That's the concept. Next is loss functions. So loss function measures how wrong the model is. So if prediction is bad, loss is high. If prediction is good, loss is low. So common examples are MAC, cross entropy. So the goal of training is simple, like to reduce the loss. Now embeddings. So vector embedding means converting text into vectors. AI is powerful. So from text, image, all those things, it will be converted to the numbers. But why? Because models understand numbers, not the words. So embedding basically help in similarity search and retrieval process. So that is the foundation of the semantic search. Now, how math powers the RAG? So retrieval augmented generation works like this. First chunk the data, then convert to embeddings, then compare vectors using cosine similarity, and then retrieve the best match. So this entire flow depends on mathematics. Now, how math powers the LLMs? So basically, LLMs combine everything, like probability predicts the next tokens, matrices transform data, attention understand the context, embeddings represent the meaning. So this is why math is the engine behind the LLMs. So what's next? So in the next lecture, we start the machine learning fundamentals. So this is where theory becomes practical. Like we will learn the supervised learning, unsupervised learning, training, testing, and real machine learning workflows. So that will be the start of building the intelligent systems. Okay. So I hope it's helpful to you. You understand the basics, like what mathematics we need to follow. Okay. So just do the like, share, and subscribe to give me motivation. We will make a full AI engineering playlist. Okay. So uh, just practice and learn the concepts what I have just delivered. Okay. Stay tuned. Thank you, everyone.